So this assignment is about the decision tree and ensemble models. There are seven different tasks in this. I like to perform like one after other. The first one is the classic gradient based model methods from scratch, and this is a demonstration of the like how the GBM is implemented and all. And post that random forest and Adaboost algorithm. Post that like I'll perform the decision tree from the scratch to demonstrate collab. Code in collab notebook file, and post that like I'll showcase the classifier technique of the GBM classifier and regression and uh, gradient boost ranking techniques as well. If we move to the first assignment, where this is a classic GBM gradient boost methods from the scratch, where firstly I'll import the required libraries. Post that the helper function to compute the standard deviation of the aggregation, and then the decision tree classification for the gradient boost. This is the code where everything is performed like finding a better split and the range from 0 to till the min minus 1. So this is a property, and this is a kind of helper function to compute the standard deviation aggregation part. And post this I'll be performing a simple data sample simulation of the data, where I took NPR range from 0 to 50, where this is the plot for this. And post that like I'll perform the gradient boost implementation here. So here I'll be performing in the range of 30, so number of estimators, and like upload the prediction model and upload the residuals, and use the residual for the next tree will be performed in this. And next the visualization of the all the residuals, and here is the residuals versus iteration 1 and iteration 2, and this is a prediction wise. And so it will perform around 10 total 30 iteration here. So as I mentioned here, the iteration count is 30, so that it will go to the 30 contribution from I to 1 to 0 to 30 till that. So it will be performed here. Post that like I have tested with one more library, and I have imported with this, and like I have performed the same steps as above, and I have just uh, took one a particular data set, and I have trained and visualized this thing. And this is the test data and train data, and this is GBM predictions for that particular thing. And this is all about the gradient boost method from the scratch. And if we move on to the next part is the random forest one. So in the random forest is all the same step. So here why the decision tree is a supporting function for the random forest. So it is stopping conditions and selecting a random features, and here we split the data into the left and right, and like performing some of the entropy and the child entropy kind of things. And post that the random forest here is the predictions, and the self of a fit. And so here is a fitting of a model will be performed and the ranges from the trees, and here is a prediction for that. And once that's done, then I'll load this particular data set, and I'll just split the data, and here is a prediction for that. And the accuracy is 0.74, and F1 score is 0.56, and F1 score is 0.60, and recall is 0.56, sorry. And this is all about that thing. And in our implementation, peach trees are created using the decision tree. The random forest class manages multiple instances of the decision tree and combines their predictions. So that's the reason like I used the decision tree in the before. So basically the random forest combines some multiple decision trees, so it's all about that. And post that if you move on to the ADA boost. So in the ADA boost it's kind of a same process, where we use a decision tree for this as well. This class implementation is basic weak learner in the ADA boost, like it determines a single best feature and the threshold to split the data. So this is all about that. And post that here is the ADA boost function, and the fitting, and the here is the decision stamp, and here is the prediction function for that. Here is the prediction function for that, and here is the weights like I have mentioned a few of the things. And computing alpha and importance of a weak learner. And post that here I'll read the data, and here is a training the model and predicting the model, and evaluating the accuracy. Accuracy is pretty good, like 0.8 and 0.73. It's a basic one, but like it computed. And here is a precision and recall versus F1 score results for the data boost one. And if we move on to the next one is the decision tree, where for decision tree also we need a helper function. Like here I'm using a gene impurity and entropy and important information gain and splitting the data and finding the best split of the data. So to find out the decision, like these are the necessary steps we need to compute it before it. And here is a decision tree classification, and here the fitting and the prediction model is computed here. And here is I loaded a wine data set for this, and post the training the distribution of the thing, and here is the prediction of the accuracy is 0.91. And it is like I printed the tree for this. So this is the tree view of this. And next I have computed the confusion matrix of class 0 class 1 wise, and the true labels versus the prediction labels. And post that, so here is the feature important calculations, where the hue and color intensity, like what are all the features they have in the wine data set. According to that, the score, important score they received out of it. And next we move on to the decision tree visualizations with the matplotlib. And this is a so overall visualizations I got for the decision tree and the predictor functions, like which I used. And post that, like the class distribution of the predictions, and this is a distribution of class 0 class 1 and class 2 vices with a count of the distributions which they have predicted for this. And we move on to the next part is the showcasing the gradient boost methods for the classifier techniques. Post that I'll perform the regression and the ranking techniques as well. So if you move on to the classifier techniques, so here some of the requirements, like I have to use a cat boost for this. And like here is the numpy, pandas and seaborn and some unnecessary libraries, and these are the module libraries to run the XGBoost and the other things. There's few of them, the decision trees has scikit-learn implementations, scikit-learn implementations, and ensemble models. From there, like I took the random forest classification, gradient boost and data boost and etc. And here as well, like from this is the one more way to implement those. And this is all about that. And this where I load the dataset, and here is the training of the dataset and decision tree and the classifier. And I have assigned to the few of the short forms, where it will be easy to predict the functions, and it will be easy to read the code. So here is all the predictor functions, and here is the test of the implementations will be performed here. So these are the scores I got for the above prediction function. So we don't have to do with any kind of previous steps, just with the importing libraries and the predict function, and it will do the thing for us. And post that, like here I have showed the MATLAB lib visualization of the all the score, like a matrix accuracy, recall and precisions. So why is the models like available on the decision tree, gradient boost and etc etc of this. And next one we go to the regression models of the gradient boosting techniques, where this is the same step I have performed as the previous one. And here is a training for the regression models I have used, and previously like I have used for the classification, a classifier model basically. And for regression one, the predict and evaluate function is performed here, and post that the training the catboot regressor and predicting that. And here I have regressors for XGBoost, Light BGM, and Cat Boost, and the training results of that, and converting the results into the data frames. So here is my data frames, like this is the one, and model and why is the RMSC score is this one. And like I have imported Seaborn here, I installed the Seaborn and post that imported. And here is the model predictions, why is the root mean square error RMSC error with comparison between the gradient boosting regression models of XGBoost, Light BGM, and GBM, and chat boost mode. And next we move on to the last part, where gradient boost ranking. So in the pip install we have two chat boosts, and same as the previous step. So here I use this synthetic data from np.random seed, like I have imported like I took the 42 as it has and like we have to mention the parameters as well for this. And here is the train and test split is performed here, and post that the training the XGBoost rank algorithm and train the model, and testing that. So same wise the for the light GBM so performed here, and train and predict, and same as the data pool for chat boost, cat boost, and here is the cat boost ranker and the train models and the predict functions. Post that here is the so this basically stores the prediction for the visualization task for the display the prediction. So this is all about that, and creating a data frame for the predictions and plotting that predictions is this one. So the model and what is the predictions, I could say this. So all three has a kind of similar results, but light BGM has a better one compared to the other things. Yeah. This is the task where I have performed like all seven tasks, and I'll upload in the GitHub file now. Thank you.